Additional dimension. Very
Cool.
cool.
Yeah, just another dimension. Can you just group it? Just make it coarse enough to, it's just another.
It's funny, it's challenging.
We can talk about this afterwards.
Go ahead.
So, I mean, is there a faceted, I know what you're saying is a semantic concept search, but is there a faceted list of filters as well? Is that, I can't necessarily see it from back here, but.
Yeah, so there's a whole lot of stuff that I'm not talking about. There is sort of the traditional search system in there. And so, you know, every single document has a bunch of metadata associated with it. And when you do a search, we surface counts and facets associated with all those metadata fields, and then allow you to say, okay, I just want to look at one particular metadata field, just like most search engines do with faceted searches.
Is there a use case that a customer used your product in a way that you guys just didn't expect it to happen? They applied it in a different direction? Or
Oh, yeah. Yeah.
Something you can talk about. I mean, I want you to disclose.
Yeah, so you know, most of our customers are in the legal industry, so that it tends to be litigation and sort of investigations. But one of our customers, they had internal customer surveys, right? So every year they sort of ask a bunch of people sort of what are all the problems, what are all the challenges. It was a giant company, one of these big consulting companies, and it normally took them several months to sort of compile all of those questions and sort of find all the common threads in it. And they were able to use a team that was about a tenth the size of the team they had before, and do it about 10 times faster than they were before, because they could take all of those sort of complaints and problem statements and all that kind of stuff, and load it in that wheel. And all of the complaints around sort of each individual thing were grouped together. And it did it automatically, right? Somebody didn't have to tell it, you know, we want to group this particular kind of complaint or this kind of complaint. It organized it. And that's one of the magics of k-means clustering, is that you don't have to tell it what each of the pieces are.
Cool. Good.
Yeah.
Are you at liberty to disclose what tools are you using?
Yeah, okay, so, yeah, that's an important point. I mean, this is a data science meetup, and you want to be able to run this stuff yourself. So all of the visualizations and the backend code that you're seeing is proprietary code for Brainspace. However, the algorithms are not. So what you're seeing here is very similar, like this right here is very similar to what you would see in any kind of graph display. It's a string. Yeah. The concept expansion is latent semantic analysis, and there are open source projects for Word2Vec and those kinds of things that allows you to do the same kind of thing. And like Spark has k-means clustering built into it, and so if you parse all your data, sort of tokenize all your text, and load it into Spark, you can run k-means clustering on it, and you can produce exactly the same result that you see on the wheel.
Are you using the Apache ML?
We have our own.
The natural language that came up with the Apache product.
We have our own tokenizers for all of this. However, a lot of the open source stuff is getting very good. And that's part of one of the reasons why I'm here, is to be aware of all the open source stuff so we can use it better.
Have you guys been able to quantify just how different legalese is from English?
Well, so here's the nice thing. The NLP that we use doesn't actually parse grammar. It just chops, it is a bag of words algorithm, right? So you get a bunch of phrases, you get a bunch of words, it becomes a feature vector, and then it goes into the algorithms.
So is proximity is the primary weighting mechanism?
No.
Well, yeah, proprietary, you don't have to talk about it.
But no, it's not proprietary.
Okay.
So specifically, what process are you
So
asking?
as you're tokenizing,
is proximity detecting, in other words, you're merging phrases, right, that
Yes.
have weighting. So how do you merge a phrase that has weighting if you're not using proximity detection?
So when we generate features for a document, like a lot of the natural language processing will just tokenize words, right? So it's usually you look for white space and then everything that's
Yeah.
in between white space is a word. We actually do something a little more complicated than that. So some software packages will do a kind of rudimentary parts of speech sort of grammar separating so that you
I
can
see.
actually find noun phrases and verb phrases that are chunks.
Okay.
And we do that.
Okay.
And so earlier when I showed you the big data query, and I listed a lot of terms that came out of that. Yeah, this one. These phrases were recognized by a sort of noun phrase, sort of grammar kind of parser.
You've got you almost have a grammar matcher.
Yeah.
Okay, I got you.
And they came out as like single n-gram features that behaved in terms of the feature space just like a single word.
I see. Okay.
Last question, right back there.
So yeah, kind of following up on this, how much data cleaning do you have to do on the text? What kind of dictionary? Do you have to do a custom dictionary for your projects?
Because one of the things that makes this product work so well is the work that we have done to clean the text. So for example, in email, when you run email through a K-means clustering algorithm, you have this scourge of email signatures, right? So, or sort of legal disclosures at the bottom of the email. And when that goes through the machine learning, it sort of tears apart the topical structure. And so you get all of the legal disclosures over here in one chunk, right? This was
So a short email with a legal disclosure gets suddenly into a
yeah.
cluster.
And the data cleaning process for getting rid of those in other products is to go in and sort of manually sort of say, okay, this is something that I want to take out. And you just sit there and sort of rip things apart. What we do is sort of automatic boilerplate detection. We do a lot of sort of really fancy version of word counts, but we do it on a line per line basis. And so we can find very frequent lines that occur over and over again, and then go through a lot of sort of heuristics to kind of figure out this is boilerplate versus normal content, and then we take it out. And one of the big selling points for Discovery, which is the name of this product, is that you can take your docking population, email anything, dump it in. You don't have to generate custom stop word lists or boilerplate or any of that kind of stuff. The system cleans the data for you and then runs it through all the analytics.
And what about abbreviations?
So abbreviations will tokenize out, abbreviations and acronyms and things like that as individual tokens. And then when they go through the latent semantic analysis process, they tend to show up as regular synonyms. So a lot of times you'll see the full word right next to the acronym for that word because it figures out that they occur in the same context. And so this latent semantic analysis stuff is very nice for finding abbreviations and acronyms and things like that.
Thanks, Joe.
Yep.